Good morning, everyone. I'm not English. Hopefully that you understand my accent. By the time you understand my accent, I should finish my presentation. The title of my presentation is a hangar project. It's a hangar 2 because it's already have another one on site. They want to build another one. The reason is because of A380 aircraft that will come in, but I can't see any different, to be honest. Just a little bit bigger and spend more money. But the interesting thing is the services things come up from the ground to surface. The aircraft is completely different. The principle is the same. And how we get into this project, to be honest, by that time, it's such as only 5 years, and we've never done any hangar project before. There's other consultant, they trust us. Okay, this is a project, crack on. And unfortunately, I was the only engineer available to do that project. Right, look at the aircraft hangar fire design. Then it's also good that you have no background of how to do a design, and then you think you will question every single thing as a fire engineer. I don't know what the other discipline. I will ask, why is that? Why you do that? Is it reasonable? Is it make sense? And then all come up to me to do a design like that. And then there's 3 questions that I will ask. What's the objective? Why? And then what fire code that we use? Is it in UK? Then do we need to follow America, or do we need to follow other code? And if everything, we don't want to know everything about fire code from the start, from the first principle. What information is available for me to develop a fire strategy? When I think about what we need to protect, what is the fire strategy for? Definitely worker. Life safety is our fundamental principle of a fire strategy. And then, is the aircraft important? It's expensive, but is it important? If I never travel, it not bother me. Is the hangar is important? Can they do maintenance not in a hangar? And I will question, because it's property protection. It's the same. If I never travel, it's important to me. And fire brigade is also very important. But from their point of view, they would not go in if a fire. Then at least I have the principle, is life safety, but in terms of the aircraft and the hangar, I need to know what the clients want in order to develop our fire strategy. What fire code that we use? In UK, guarantee there's no fire code related to a hangar, but allow you to use the principle to develop a fire strategy. And also UK like to use passive fire protection, like putting compartment and put a wall, seal everything. But for big hangar project, you can't put a wall in the middle. And then American have a specific code called NFPA 409 that is particularly designed for hangar project, but they mainly use active fire protection. Okay, let's have a look. NFPA approach, what American do. they use foam system, like if you spot a little bit of flame, and then this will happen. Yeah. Just a little bit, yeah. Because it's important that flame can spread everywhere, damage the whole airplane, damage the whole hangar, and this is what they do. And then within, say, 60 minutes, it's flood. And then the question come up is, if a little bit accidents at the corner, flood everything. Oh, I don't like it. Yeah. And then aftermath, yeah, that is, it's bizarre, yeah. And then there's an alternative. We call that, it's called oscillation sort of nozzle. It's positioned in the best location. In case of a fire, you sort of spread the foam like that. Yeah. This is the hangar, and that part is you park your the airplane here, and this is back of house. And strategically locate 3 positions, and there's a fire, it's spread. Yeah, to cover the potential fuel spill location. Yeah, this is another. And this is how we operate. Yeah. Yeah, this is how we operate. But there's a problem. When you have a lot of stuff, you got blocked by your stuff. Yeah. Although this is related to maintenance or management issue, but it's happened. And then, okay, we know the principle, we understand how it works, and then is it necessary? And then I ask the client, ask the operators, read a lot of article, and then we understand what activity they're going to do in the hangar, and have a quick look through, nothing special, but it's it is important to know, but we're not necessary to go to understand how this every single thing works, and also what is given. But the first thing is quite crucial, right? In the beginning of the project, they said that it's only park the airplane here, there will be no fuel. And then after 2 meetings, they can't come back. Well, if I have an incident that the plane ready to take off, and then it's a problem. They have to drive in there. This means it will full of fuel. And then we have to consider fuel as well. And then fuel is most likely source of large fire load. Yeah, I will explain you a little bit later. Gasoline Jet A, that is to be honest, really safe gasoline, while compared to the petrol we use, but it is less safe than diesel. And then high, it's quite high, and then we create a smoke reservoir that people can evacuate. And then temperature at the roof not likely to cause structure failure due to fire suppression, if the fire suppression work. Yeah, I will prove that whether it's actually work or not. The volume will allow quick egress away from the fire source. Yeah, if you see the picture before, that the main fire source in the middle, and the people work around it can evacuate. And there's no painting, and then also we separate the commercial and the workshop by 2-hour firewall. And the one thing missing here, and ask the operator, when you do maintenance, is the door is kept open, or it is kept open or closed. They said that in a field situation, that the door will open. Yeah, that is a massive opening. Right, and then after all the information I have, what is known, and then I need to start my research, start my data collection in order to do the first principle fire strategy. And after search a lot of information, and I found that it's different fuel tank, and then the size, and how we're going to maintenance, and end up we find a tank that the inter tank is that size, and possible risk is when they maintain the coupling or the pump, and that fail, then the gas or the fuel from the tank will flow to the floor. Yeah, and then this is how the first engineering bit come from. Is a conservation of energy from potential sort of energy into kinetic energy. Yeah, everyone know. Yeah. And then what next? This is to be honest, this is the most difficult part. I try to search, try to find information. What happened if water type of things put on the floor? Yeah, I did it to my team. I actually put water on the floor and then ask, what do you think? It's really difficult to predict what happened. And the design team gave me 3 possible solutions in terms of the drainage system, to how to drain the sort of water or whatever. Actually, the drain is to collect all the spilled fuel, and then I don't know whether they reuse or they recycle. Yeah, but for example, and this is the exact drainage strategy for Hangar 1. Yeah, that's the one that next to it. And if we, and this is the leakage hole, and the potential fuel spill to the floor is that size. And then for the next one, that we found a interesting fire protection system that is called Viking Grand Nozzle System. I'll show you the picture how this works later. And potential fuel size beside that. And then the third one is what the design team proposed. 4 location, and then there's a potential size. And that involves a lot of consideration, like is the surface of the floor smooth enough for the fuel to spread quicker, and also how thick of the fuel on the floor, and also if there's a fire, how quick of the fire spread from one point to the whole fire size. There's a lot of questions to answer, but I managed to sort of take those information, and based on published data, based on research paper, based on other information, and then end up, this is a summary of the fire scenario. And we know that there's a tank size, and then we know the opening size, and then the way that 31 liters per second onto the floor. And then when we have a fire size, we have to apply a 155% factor when you do the heat release rate calculation, and end up is 398 megawatt. And I don't know how if you burn a normal car, yeah, you see a lot, yeah, right. That fire is talking about 4 megawatt to 8 megawatt, a normal car fire. Yeah. And now we are dealing with 398 megawatt. It's huge. It's huge. When I get that result, I was frightened, like I am now. And when I do all the calculation, that fire would last for 34 minutes. It's a really long time. Then will the hangar survive? Will the other things survive if the fire suppression system doesn't work? And then I put it in a CFD because we can't like Anton do a test. We can't do tests. Yeah. And when the first 16 minutes is a quite crucial time to suspend the fire based on NFPA. And then I have a look. And then you can see it's only a little bit here that is around 570 degrees. And then majority of the area or the volume is quite low. It's around 200. And then the condition is the opening to outside, or the door to outside fully open. And then go to 200 seconds, and still, I think it's around 460. Yeah, and then after 10 minutes, yeah, this is what the NFPA recommended. After 10 minutes, they should suspend the fire completely or flood the whole hangar. And well, the temperature is reasonably low, and then that's why from that we can say, right, it's not necessary to do any steel protection to the roof. Yeah, it saves a lot of money. After we have done that, and then we understand how this works, we develop the fire size, and then we go to fire detection system. This is different to a smoke detector in here or heat detector. It is really specific. We don't want sudden accident. We don't want false alarm. Any false alarm will flood the place. You can't use the hangar. And then we also need to understand they do welding, they do hot surface things, they do some for maintenance. You have to allow them to do something. And the hangar they use the UV, is virtual wireless, and then infrared, something like that. And this is really good, but we recommend even much better. Yeah, when we consider location, when we consider coverage, that IR is better. This is our recommendation. And also at the same time, there was an accident in the other airport that there was a training ground quite close to the hangar, and some of the detector detected the training ground fire, and then flood the whole hangar. And then we don't want that, and then think that the IR is a better solution. And also we recommend a fire suppression system. This is the one that we saw that before. And when there's a fire, because it's quite close to the field base, it will tackle the fire within 30 seconds. Yeah, and this is a new product. We recommend the Cayenne fly to America to have a look, and then end up they decided not to build the hangar too. It's a shame. But it's good that we tell them there's things that in the market is new. It is important. It tackles the issue, and this is sure this is what they want. If not, they would not spend time to go to America to see that design. And the conclusion. Yes. we developed that from the first principle. We understand the fire, how it's developed, what is the incident, what is the risk, and then we provide options to different drainage system, and definitely life safety has been considered, including fire brigade. And then we recommend the structure is not necessary to be rated. And then we, although I only mentioned one page, I actually have a report to discuss the fire detection system and suppression system. And the interesting that Kayan and the authority are so impressed. They also give me a rabbit sort of things like that. And that is important step of us. We understand that, and in order when we have other project comes in, we can provide a better service. And we use that knowledge, apply for the NDIA, that is the biggest hangar project on Earth at the moment. That and we managed to get the contract, we to do the review, and the project went successfully. Thank you.